What's up everyone, Kelvin here, and this video today is based on the NEP simulator which I currently have for the CCNA routing and switching 200-120. Now I thought it'd be a good idea to actually demonstrate this troubleshooting lab, as I have been doing a few practice exams for my ICND1 cert, and I have come across topologies like this which have asked you what the destination source MAC address and IP source and destination address will be once it's traversed the network or the topology. So I thought it'd be a good idea to go through this simulator to kind of reinforce that knowledge within myself, but also to help those out that may be struggling with this switch forward troubleshooting scenario ready for the ICND1 exam. So as you can see, the topology is there on the left hand side, and we're just going to briefly run through the overview. Now it says this lab begins with a working internet with PC1, PC2 and switch 1 in one subnet and switch 2 in another. Your job is to examine the network using show commands to predict out which, that doesn't make sense, to predict out which interface frames sent by PC1 would be forwarded. Note that the topology figure omits two links that are essentially disabled for this lab. This link between switch 1 and switch 4 is not shown, nor is the link between switch 2 and switch 3. These links are disabled so that spanning tree protocol topics can be omitted from the discussion. Okay, so the goal of this lab is to predict the path taken by two frames sent by PC1. The first frame is the broadcast frame with destination MAC address, all Fs, which is the broadcast address, and the second frame is destined for router 1's fast Ethernet 00 interface with MAC address, which is located here. So what we're going to do is we're going to run through the detailed steps below, and if we start with step 1, we're going to connect to switch 3 from the simulator user interface, which is we're already on here, down here. So just to make this more visible, I'm just going to bring this up a little bit more. So the passwords are all set using Net Simulator. For this one we're using Cisco Press, so I'll go ahead and enter that. So we're going to enter the appropriate show command to view the VLANs and their assigned ports. What VLAN is PC1 in? So to do that we need to do en Cisco Press again, and we're going to do show VLAN brief, and it's asking us what VLAN PC1 is in. So we know, looking at this topology, PC1 is on fast Ethernet 011. So 11 is here, so it's in VLAN 2. Okay, and we have yeah, that's fine. Okay, so we'll go ahead and enter that answer. So it's in VLAN 2. Check answer. The show VLAN command can be used to view VLANs besides the default VLAN 1. There are two other configured VLANs 2 and 3, which we can see here. PC1 attached to fast Ethernet 011 is assigned to VLAN 2. So we know we got that one right. So we'll move on to step 3. So step 3, assume a broadcast frame is sent out PC1. According to the output of the show VLAN command, on what interfaces will switch 3 flood the frame? Okay, so it's going to flood the frame through the gigabit 01 interface, and then it all depends on, does it say down here? It all depends on what VLANs these are all assigned to, whether the PCs receive them or not, but it'll flood it over switch 1, gigabit Ethernet 01 to switch 2, then switch 4, and it'll go to PC 2 if it's in the correct VLAN. And then it'll stop, if I'm correct, at router 1, because routers don't forward the broadcast. So, okay, assume the broadcast frame is sent out of PC1 according to the output of the show VLAN command, and what interfaces will switch 3 flood the frame. So it floods every interface apart from the sender's interface. Okay, so it's going to flood the gigabit 01 interface. So with the X section of the port the frame was originally received on, which is Fast Ethernet 11, which I mentioned, a broadcast frame is flooded out of all ports assigned to the same VLAN and out trunk ports, but is never flooded out the port which the frame arrived. However, the show VLAN command only lists one port in VLAN 2, namely the incoming port Fast Ethernet 11. So this command seems to imply that switch 3 will not forward PC1's broadcast anywhere. Yep, it does for now, because like I say, it does forward it out of trunk ports as it says there. However, we know that gigabit Ethernet 01 is a trunk port because it's not listed here next to gigabit 02, and it's not listed anywhere else, so it's been removed because it's a trunk port. So it'll go across the trunk port, but then like I mentioned earlier, we don't know where it's going to go from there because we don't know what's assigned to VLAN 2 from here. We know that probably gigabit 01 is a trunk, is set up trunking with switch 2, but again we don't know where the broadcast will go from there. So for now we'll assume that the broadcast won't be forwarded. So we're going to move on now to step 4. We're going to use the show interface status command and look for interfaces in a connected state that are either trunks or access ports in VLAN 2. Do you find any other ports out which switch 3 is likely to flood PC1 broadcast? Okay, so we'll do that. Show interface status. Okay. So if we just do more. So like I said earlier, we know that gigabit Ethernet 01, it will forward the broadcast over the trunk, and it is connected and it is trunking. Let's have a look. That's the port the frame will be sent off. Well, come from, sorry. So yeah, we'll go ahead and enter gigabit 01. Yep, the command lists gigabit 01 as a trunk. So up the last question we kind of jumped ahead a little bit. As well as Fast Ethernet 011 as an access port in VLAN 2. Switch 3 will flood the frame from PC1 which arrives on Fast Ethernet 011 out of gigabit 01. Okay, so now we move on to step 5. Connect to switch 1. So we'll just click that there like that. Assume the broadcast frame sent out of PC1 was forwarded by by switch 3. So that frame from PC1 has come up to switch 3, and because trunk is set up on gigabit 01, it's going to forward that broadcast frame to switch 1 now. So now we're on switch 1. According to the output of the show VLAN command, on what interfaces will switch 1 flood the frame? So we'll have a look now. Okay, so VLAN 2 fast Ethernet 011, so the broadcast frame will go to S1 from fast Ethernet 011, and we also know that gigabit 01 is set up as a trunk because it's not listed here, and obviously gigabit 02, which the broadcast has already come across. So what interfaces will switch 1 flood the frame? So it's probably going to be F011 and gigabit 01. The output lists only ports in VLAN 2 F011, so switch 1 should at least forward the frame onto this port. However, the show VLAN command does not list trunks as being associated with any particular VLAN, which is what I mentioned before. So it still will go across gigabit 01. Okay, so moving on. Again, examine the interface status and look for trunks that were not listed in the output show VLAN command. Is switch 1 likely to flood the frame out of any interfaces other than fast Ethernet 011? So we have jumped ahead a little bit here again. But what we'll do is we'll do the command again, and there we go. So it's going to forward the frame, the broadcast, out of gigabit 01 onto switch 2, as we've already mentioned. It won't forward the frame out of gigabit 02 because that's here, and that's where the broadcast has come from. It's passed from switch 3 to switch 1. So it's not going to forward it out of that. And fast Ethernet 011 we already have identified. So we're going to go ahead and put gigabit 01. The show interface status command lists 2 trunks, gigabit 01 and gigabit 02, which we identified. However, because a frame from PC 1 through switch 3 arrived on switch 1's gigabit 02 interface, switch 1 will flood the broadcast out of gigabit 01 but not gigabit 02. What a mouthful. So we identified that already, which is good. So step 7, connect to switch 2. So now we imagine the broadcast has been passed on from switch 1 to, it's also gone to S1 PC, but this, the frame we're following is the broadcast which has now gone to switch 2. So connect to switch 2 and look for interfaces in a connected state that are either trunks or access ports in VLAN 2. Out of which ports will the broadcast frame be forwarded? Why won't the frames be flooded on switch 2's fast Ethernet 011 and gigabit 02? Well, we shall have a look. So we already can see here that the frames will be forwarded out of VLAN 2 because there's no interfaces in VLAN 2. So we already know that, and fast Ethernet 011 is in VLAN 3, so it won't be forwarded to another VLAN. And gigabit 02 Where are you? We'll have to do is show interface status. So gigabit 02 doesn't seem to be connected. So that's why it won't forward out of gigabit 02, but it will forward through the trunk on fast Ethernet 010. Okay, let's do a show run. And gigabit 02. So it's showing not connected, however the interface doesn't seem to be shut down administratively. Gigabit 02. Yeah, so the lines up, the protocol's down. Auto duplex, auto speed. So there might be a problem with the actual link. However, it's not asked us that. So why won't the frame be flooded out of switch 2's fast Ethernet 011 and gigabit 02? Well, fast Ethernet 011 is connected to VLAN 3 and gigabit 02 line is up and protocol is down. Okay. The frame will be sent out of fast Ethernet 010, which is what we identified, a trunk only. It will not be forwarded out of gigabit 01 because that is the port the frame was received on. We already know that. It will not be forwarded out to gigabit 02 because the trunk link is down. We identified that. And finally, it will not be forwarded out of fast Ethernet 011 because the port is assigned to a different VLAN, VLAN 3. We also identified that from the one that the frame originated on VLAN 2. Yeah, we know that. So part 2 is an analysis of broadcast frames from PC1 with switch 4. So part 1 showed us how a broadcast frame sent by PC1 would be forwarded based on the initial status of the links in the lab. However, those broadcasts did not reach switch 4. No, they didn't. Mainly because the links connecting other switches to switch 4 are down. Part 2 guides you through the process of enabling the links to switch 4 and then predicting the flooding of broadcasts sent by PC1. So we're going to connect to PC switch 4 now, move into enable mode and display the status of all interfaces. Okay. So we've done that. What is the current state of switch 4's interfaces listed in the topology and the topology map of the simulator? What does the interface state imply about the configuration on each of the interfaces? So if we look at gigabit 01, that's disabled, so I'm guessing it's shut down. Fast Ethernet 02 is connected, however we don't know what VLAN it's in yet. Oh yes we do, sorry, it's there, VLAN 2, so the broadcast probably will go to PC2 as well. And that's all we need to worry about. So if we do a show run, gigabit 01 is shut down. So we need to obviously apply the no shutdown to activate the interface, and then switch port mode trunk's already been configured, so the trunking should enable once we apply the no shutdown command, but we'll follow the instructions. It implies that gigabit 01 interface is administratively shut down. Use the enable command to move to enable mode, then use show interface status command and look at the interfaces. Fast Ethernet 012 is connected state, which means the interface is working. Its gigabit 01 interface is in a disabled state, which implies the interface has been configured with a shutdown command. Configure switch 4 to enable interface gigabit 01. So we'll configure the no shutdown command. First gigabit 01, no shut, and there we go. We can see now that the trunk has formed. If we just do a show interface status, it's connected, trunk full, great. So now that's connected. Move back to switch 2 using the simulator interface and repeat the show interface status command, imagining that PC1's broadcast has just arrived on switch 2's interface, out of which interface will switch 2 forward the broadcast and why. So we know that the broadcast is going to be forwarded to Fast Ethernet 010 already. We won't go to Fast Ethernet 011 because that's in a different VLAN. And we've now activated this interface, but we'll verify that with gigabit 02, so the broadcast should reach switch 4 and PC2 as that interface is in VLAN 2. So we'll check show interface status. Gigabit 02 is now connected. There we go. Trunking, so that's good. So it'll forward the broadcast out of Fast Ethernet 010 and gigabit 02. Switch to show interface status command lists Fast Ethernet 010 and gigabit 01 and gigabit 02 as trunks, but it lists no access interfaces in VLAN 2. The frame arrived on gigabit 01, which is here. So switch 2 would forward the frame out Fast Ethernet 010 and gigabit 02, which we did figure out, which is good. So now we're going to move back to switch 4 using the simulator and do the show interfaces status, imagining that PC1's broadcast just arrived on switch 4's gigabit 01 interface, out of which interface will switch 4 forward the broadcast. Okay, does the broadcast arrive at PC2 and why? We already know that because we've already jumped ahead. So yes, the broadcast will forward to PC2 because it is in VLAN 2. Switch 4 show interface status commands list gigabit 01 as a trunk as well as Fast Ethernet 012 as an access interface in VLAN 2. The frame arrived on gigabit 01, which is here, so switch 4 would forward the frame out of Fast Ethernet 012 to PC2, which is good. So we've done that. Now imagine the frame coming from PC1 that is destined for router 1's Fast Ethernet 00, which is here. In part 3 you will analyse the path taken by the frame. So we're going to connect to PC1 and issue a ping command to 172.16.01. So we'll do ping 172.16. Oopsie. Help if it were writing. Ping 172.16.0.1. and that's successful. Then connect back to switch 3 and enter the command to view the MAC address table, out of which interface will the frame destined for 0200 A, which is the interface of router 1 fast Ethernet 00, will be forwarded. So we shall have a look at the show MAC address table. Nearly forgot that command. So we know (0 to 100 AAA gigabit 01), so it's going to be forwarded out of that interface. So gigabit 01. The command to view MAC address table is show MAC address table. We've done that. The frame will be forwarded out of gigabit 01. It will not be forwarded out of fast Ethernet 011. We already know that, because that is the port the frame was received on. Connect to switch 1 and examine its MAC address table, based on the output of which interface will the frame be destined for. So 020, so it's going out of gigabit 01 again. Yep, we know that. Connect to switch 2. We're going to do the same again. And we can see here. There we go. So it's going to be forwarded out of, yep, that's right, fast Ethernet 010. Yep, that's fine. And a list of frame from PC2 to PC1. Now imagine the frame coming from PC2, which is here, that is destined for PC1's MAC address. In part 4 you will analyse the path taken by this frame. Okay, so connect to switch 4 and examine its MAC address table. At which port will the frame be forwarded? Well, we know already which frame is, port is going to be forwarded out of. Show MAC address table. So we know the MAC address for PC1 is listed here, and it is there. So it's going to be forwarded out of gigabit 01, sorry. Yep, that's correct. Connect to switch 2. Examine the MAC address table. Same again, identify the MAC address, which is obviously the same one. There we go. So gigabit 01. Yeah. Connect to switch 1. Examine the MAC address table. We can up arrow for that. And gigabit 02. And connect to switch 3. Examine the MAC address table. And it's there. Fast Ethernet 011. And there we go. That's the end of the lab. So hopefully you kind of understand how broadcast frames and frames are generated and sent around a switch or a switch network, and you can kind of identify where frames are going by looking at and using different show commands. So we 100% on that lab, so we know that that's done. Thanks for watching.